All right, number 3. Sketch a graph of a line that passes through the origin and whose y value changes by 3 units for each 5-unit change of the x values. Okay, now I know you guys don't have graph paper, but this is something that you can do really quickly. Even though you don't have graph paper, just watch what I'm going to do here in this case. I'm just draw a big L. And we're going to begin to plot this data. All right, so like I said, you just need to draw a giant L in this case, and you can space it out as best you can. So I'm going to go and number this off here, put my 0 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. It's going to be our horizontal axis, and then the vertical axis is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, the directions here are a little bit unique. We have to be really careful here. So it says, sketch a graph of a line that passes through the origin. Let's stop there. Passes through the origin. So that means we know that the origin is right here. Okay? That's going to be the first part. So that's going to be an ordered pair. So if I know that my x and my y values are going to be here, I'm going to have a 0 and 0. Okay? Now look at the next thing they asked us to do here. It says there, pass through the origin and whose y values change by 3 units for each 5-unit change in the x values. So what that means is for every 5 here, it's going to change to 3 here. Now let's model that as well for a rise and run. See, the y value would be going up 3. That's my change of the y. There's my up 3. And then my run of 5 to there. Oops, I went too far, darn it. Run of 5. And that's where we showed that have that 5, 3. So we got 5 and 3. So we have another point there. So if we do that again, from this point, if I rise 3 and then run 5, you see I have another point right here, and that ordered pair would be 10 and 6. And so when we have that spot there and we have a line going through those points, you can see how that would make the graph look like that. Okay? So I want to make sure you understand that part. If you need to pause it, review it, that would be okay. But notice how we're going up 3 over 5, up 3 over 5, and it ends up giving us that ordered pair of 5, 3, and 10, 6. All right, part 4. It says write an equation for the line in part 3. Okay, so the equation for this line that we have there in part 3, we want to understand that, what's going to be going on there. And if you recall from our classes, as well as previous times, the equations of the lines are going to look like this. That m is that ratio, or that rate, or that scale factor, or that constant proportionality. All those different pieces that we would come into, that ends up being what goes in there. So they're telling us that it's going to be a ratio. But we want to also notice that if I look at this information, or what's going on here in this case, if I have my equation here for 1, it's going to be y equals something times x. So if I put 0 in here, I would get 0. But if I put 5 in here, I have to end up with this 3, and that ratio we already said was a 0.6. So we could put 0.6 here, like that. But we could also sort out that if I know that it's going to be this ratio of this 3 to 5, we could actually take that ratio and put it in here completely just the same. So we'll have the 0.6 or 3/5 of x is going to be going in there. So you'll see that if we plug that value in, if I do 5 times 0.6 or 5 times 3/5, either of those, you'll see I would equal 3, or in this case I did 0.6 times 5, I would get 3 there, and that's how that works. So the ratio would go in here. So the equation that you would come up with, and I think for our purposes, because what they gave us, we're going to put the 3/5 in there. Now the reason why we don't put anything else there is because there's that if we put a 0 in, we would get 0, and you can see that the origin goes through. So that's our overall equation. Y equals 3/5 x, or y equals 0.6 x. Either of those would work. So actually that was part A there. So now we're looking at part B. Part B says, what is the coefficient of x in the equation? Well, that means what's going with that x, what is right there with it. So we have, again, the 3/5 or 0.6. That's the coefficient that's with the x. All right, 4C. This is a really, really great question. How is the coefficient related to the steepness of the line represented by the equation? Okay, so if we look at it in terms of this 3/5, the 3/5, that initial ratio they gave us of the stairs, that 3/5 or 3/5 ratio being, or the coefficient related to the steepness, notice how the stairs here, we actually went up 3 to the right 5, up 3 to the right 5. So you see that constant repeating of the 3 and the 5, the 3 and the 5. Remember, we always said that the change of the y over the change of x, that ended up being, that's like 3, 3, that's on top, that x is going to be 5, 5. That's how we have that. So the connection specifically is the coefficient shows the steepness of the graph. The coefficient shows the steepness of the graph for up 3 and right 5. And number 4D, how is the coefficient related to the steepness of a set of stairs with this ratio? Well, in this case, thinking specifically about the stairs here, that basically shows the relationship between the steepness of a set of stairs with the ratio is there's going to be a movement of an up 3/5, up 3/5, but the general steepness is showing that this related to the set of stairs is the same process of showing the steepness when it comes to the coefficient, when it comes to the equation. All those are connected. So if you have an easy step, like if I have a lower rise and a longer run, the steepness will not be as high. But if I had a higher run and a shorter, or a higher rise and a shorter run, it would be much steeper. So depending upon that, it shows how steep it'll be. All right, guys. Hopefully that went smoothly. We're going to get the ACE work. You only have one question. Problem number 1 for this particular problem. Or, yes, question number 1 for this problem. Let's take a look. All right, here we go. Plans for a set of stairs in front of a new community center use the ratio of rise to run 2 units to 5 units. Recall the carpenter's guidelines state that the ratio of rise to run should be between 0.45 and 0.60. Are these stairs within the carpenter's guidelines? So basically you're going to do this ratio, figure out if it's going to be a yes or no. Sketch a set of stairs that meet the rise to run ratio of 2 units to 5 units. Sketch a graph, just like we did on our work here. Y values changing by 2, each x value changing by 5, and write an equation of the line. That's it. All right, guys. Hopefully this helps. Hopefully we're getting it, and we'll see you next time. Take it easy. Bye-bye.